This is on page 390. No, that's not on 390. 418, which is very close to 390. That is not the right questions, then don't do 4 and 12. Do questions 3, 4, and 9. And the pre-quiz is up already. So, the steps for solving a logarithmic equation. A logarithmic equation is when there's an x inside of a logarithm. And the steps for solving it are to first combine as a single logarithm. The main important thing that we're doing here is in the red box, that to solve a logarithm, if you have a single logarithm, you can change it to exponential form, and that you can do by using the definition. That's the most important step. It's also the key step that seems to be that everybody always forgets. So solving for logarithms can be done by using the definition and changing it to exponential form. In order to use the definition, we have to have a single logarithm first. That's why there's step 1. Once you change it to exponential form, it will be obvious how to solve. It'll turn into something that you'll go, oh, I know how to solve that, and then you'll be able to solve it. Then finally, just like square root equations, exponential equations, you need to check for extraneous roots, because sometimes you will get an answer that actually doesn't work. And the reason and the way that you check for it is that you are not allowed to take the log of 0 or the log of a negative number. And if you do, that's not possible, so we have to check our original equation for that. So in the example that we have, right now we have 2 logarithms in our equation. So step 1, we have to say, is there a log law that lets us combine those as a single logarithm? Do we have a log law that says log plus log? Yes, we do. That's the same as multiplying inside of the logarithm. So 9x times x would be 9x squared. And now I've done step 1. I've combined it to be a single logarithm. Now we have to use the definition of a logarithm. In this logarithm, the base is 3. The exponent is 4. And the answer is 9x squared. So we changed it from log form to exponential form. And then you look at that and say, hey, I can solve that. That's just an x squared equation. I'll get the x squared by itself, divide both sides by 9. 3 to the 4 is 81. 81 divided by 9 is 9. And square root both sides. Remember that it could be plus or minus 3. So that solving part, once you've changed it, is actually fairly easy. And we get 2 answers, one where x is positive 3 and one where x is negative 3. And now step 4. We have to check our original equation for extraneous roots. You cannot take the log of 0. You cannot take the log of a negative number. So if I plug in positive 3, the only thing you're checking is to make sure that only positive numbers go in. So 9 times 3 is 27. That's OK. I look at my second log, log 3 of x. If I plug in 3 there, I have log 3 of 3. That's OK. So this answer is fine. But when I plug in negative 3, 9 times negative 3 is negative 27. I have a negative number inside of my logarithm. And that answer would be bad. Okay? Further explanation of why you can't take log of 0 or log of negative number. So a further explanation of why something like, why is log 3 of negative 5 bad? Well, let's say it's equal to x. If you change this to exponential form, this is asking 3 to what power is equal to negative 5? And sometimes this is easier to think if you're thinking in exponential equations. If we think about 3 to the x as a graph, it looks like this, right, with an asymptote at 0. Can you tell me on that graph when the y value is -5? It can't. It never is. Can you see that it's never any negative number? It's not 0 either because there's an asymptote of 0 there. So there's another explanation of why we can't take the logarithm of 0 or the logarithm of a negative number. Oh yeah, as I said before, the questions for practice here are 3, 4, and 9.